Okay, so we're going to finish up. We stopped when we first came up with the quadratic equation. I showed you how to find the quadratic equation. It's not something I'm going to ask you to do on a quiz or a test or anything like that. I just think it's good, especially for an honors class, to be able to figure out where the quadratic formula came from. So there's a difference in some of these words. So if I said a quadratic equation, all right, let's just do a little review right here. If I said a quadratic equation, what am I saying? It's this. This is what I'm talking about. Whoops. When I'm talking about a quadratic equation, that's an equation right there, okay? Everybody with me? We did this. Now on Friday, what we did was we took this, we learned how to complete the square, and in fact, in my Algebra 2 class, just today, we learned how to complete the square, all right? So it's something, and that's only chapter 5, I think, or something like that. So anyway, if you didn't know how to complete the square, I showed you how to do that on Friday. So then we did some work, okay? Boom, 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 boom. Here's the work, okay? That's all the stuff that we did. And we came up with something called the quadratic formula.
Is that a zero?
What? That? What? This? Yeah, equals 0. All right, the quadratic formula. Does anybody have it memorized yet? It's negative b. This is something you should have memorized, okay? You should have it memorized because it's very useful. It's very popular, very popular. I think I even said when I taught this before, in high school math, this possibly could be the most popular formula, equation, whatever you want to call it, in high school math, all right? Maybe next to Pythagorean theorem, maybe, all right? This is one of the ones that you really need to know, all right? Plus or minus square root b squared minus 4ac over 2a. Notice everything is over 2a, not just the square root, not just this thing right here. Girls, up here. All right, so that's the quadratic formula. You need to memorize it. I think that was the last thing I said on the class on Friday. Okay, memorize this thing. You have to know it. I'm not going to put it on your quiz. I'm not going to put it on your test. You have to know it, and you have to know how to use it. And that's what we're going to do today. All right, we learned how to develop it, how to come up with it on Friday by completing the square. Now we're just going to use it. And I'm telling you right now, I'm going to write this in here. So completing the square. And that might be kind of new to you as well. It really shouldn't be, but I have a feeling from hearing some of what you're telling me is that you really didn't do much of this last year. But that's something that you should know how to do is complete the square. You can take any quadratic equation. Do you hear me? You can take any quadratic equation, no matter what the numbers are. Okay, but it's got to be in this form. Okay, ax squared plus bx plus c equals 0. Any quadratic equation, and you should be able to solve it by completing the square. You should also be able to solve it by using the quadratic formula. So which one are you going to use? Well, sometimes books will tell you, solve this a certain way. They might say solve it by completing the square. Okay, or they might say solve it by factoring. Or they might say solve it by graphing. Or they might say solve it by using the quadratic formula. There's potentially 4 ways to solve a quadratic. One would be by graphing. And they do this in here, so this is good to write down. There's 4 potential ways to solve a quadratic equation. Why do I say potential? Why don't I just say there's 4 ways? Because you can't always solve for it by graphing. You can't always solve for it by factoring, because not every quadratic expression you can factor, all right? But here's potential ways to solve a quadratic equation, and that would be by graphing. Not the greatest way to do it, because it's not always super accurate, but it's a potential way to solve for a quadratic. You could do it by factoring. Again, that's not always going to work, because some things just don't factor. You can't factor it. All right? So sometimes it works, sometimes it doesn't. Sometimes it's way easier factoring a quadratic to get an answer than it would be doing the other 2 ways. But these 2 will always work. Put a little star next to it. Okay, so completing the square And on some of these problems, they ask you to do it 4 ways. All 4 of these ways right here. That's why I'm writing them all down. Okay, completing the square. And the 4th way, obviously, it's already written down. The 4th way, and this will always work. Completing the square will always work. And this one, the quadratic formula, will always work. Okay? And on some of these problems, it's going to say to do it all 4 ways. I'm still debating on whether I want you to do it. I probably will not have you do that on a quiz. I probably won't have you solve for it all 4 ways. Now again, this, I'll put a question mark because you don't always know if you can factor it by graphing. All right, there's some things that you can't. It's impossible. Same thing with factoring. Okay, there's some quadratics you can't solve by factoring. Some you can. All right, and when you can, sometimes factoring is the best way to do it. It's the quickest. It's the easiest way to do it. Right, but you can always do it by completing the square, and you can always do it by quadratic formula. What's better, completing the square or the quadratic formula? I don't know. Depends who you talk to, but most people would say that the quadratic formula is probably the better of the 2 ways. It's usually, not always, usually a little quicker, little easier, saves you a couple steps here and there. All right, so the quadratic formula is right here. Let's put it in a box. There's your quadratic formula, and that will always work. And a lot of times, it's the best way to do it. Okay, sometimes it's the easiest way to do it. So it's important. So, but any quadratic, you can always use a quadratic formula to solve for it. Okay, enough of that. The first example that they give you to use the quadratic formula is kind of weird. Usually they give you something with real super easy numbers, but they decided not to do it on this one. I don't know why. But they refer to the story at the beginning of the lesson. If you flip to the beginning of a lesson, they always have a picture there. Then they got a little story talking about it, and it's kind of a physics problem. It's on page 213. I'm going to write down all the information you need to know. You can turn to it if you like. But on page 213, there's a little story, a little picture that goes with it, and it talks about this. But this is basically what they talk about. Did I write this down? I thought I wrote that down in my notes. I don't think I did. Oh, no, I was thinking of another problem that we did. I'm just going to write this down, okay? I don't want to spend too much time on this. So it says solve. This is kind of like a physics problem, all right? And somebody that can do, somebody that can measure things came up with this formula for this physics problem, and here it is. It's 80 t. It's t for time, all right? They're not using x, they use t. And then 16t squared plus 3.5 equals 0. And what we have to do is we got to solve for t. Looks kind of daunting. It looks a little tough. But with the quadratic formula, it makes things a lot easier. First of all, though, I don't like the way that it's written. Okay, do you remember what the quadratic equation was? It was what? ax squared. The squared was first. Okay, then the x was in the middle, and the constant was at the end. So what we're going to do is we're going to switch this around a little bit to make sure that our squared is first, then our constant, or then our just our t in this case is in the middle, and then the constant is at the end. All right, so how would I rewrite this then? What goes first? Well, it's not just a 16 though. This is where you got to be real careful. It's a negative 16, right? So make sure you put negative 16 t squared. So I'm done with that. What goes next? Plus, good, 80t. All right, so you're done with that one. What's next? Plus 3.5 equals 0. So first of all, that's the first thing you need to do. Okay, is write it like this. I'll write that quadratic formula here in a second, but you have to identify your A, B, or C. When you're first learning the quadratic formula, you did quadratic formula last year, right? I think somebody got some nods last time I asked. Okay, that negative b plus or minus. Did you do it or not? Abby, tell me. Algebra 2? Yeah, in Algebra 2. It's definitely an Algebra 2 topic. I mean, if you were in a really pretty accelerated Algebra 1 class, you may have done it in Algebra 1. Okay, but if it wasn't like a real rigorous Algebra 1 class, you probably would not have done that in Algebra 1. But definitely in Algebra 2. So here's something a lot of people like to do. You can do it if you want. After you get used to these things and you get really familiar with it, then you probably won't have to do this. But this helps out if you're first learning it. So what is the a? Remember the ax squared plus bx plus c? What's the a right here? It's ax squared. It's negative 16. That's right. So that is your a right there. Okay, what's your b? 80. And what's your c? 3.5. Some people like to do this. You don't have to. I'm just telling you that some people like to do this. They like to list them out. So a is negative 16, b is 80, and c is 3.5. The nice thing about the quadratic formula is you really don't have to solve for anything. It's already been solved for you. All right, so let's write it down just so we can see it again. I already wrote it earlier. And the more you write it down, the easier it is to remember. Okay, if you write it down over and over and over again, then it should be easy to remember. Gideon, I guess you got this already down. You don't need to write it down, do you? Do you think it's probably the best that your head's down on the desk, not watching this at all? I don't think it's probably for the best. I'm just saying. All right, so if I wanted to solve, now in this case it's not x, what is it? What are we actually solving for here? Not x, but what? T, all right? All depends on your equation, what you're solving for. Again, this is a physics problem, probably has to do with a parabola, right? Probably something being thrown in the air, maybe a rocket going through the air, something that starts here, makes a parabolic motion, comes down like this. We're trying to find the t, the time. Okay, this represents something, this does, and this does. Don't worry about all that stuff. Let's just learn how to solve for t. So what do? Negative b. Well, b is 80, so what's negative b? Negative 80. Plus or minus, big old square root. Now we go b squared. Well, b was 80, so what's it going to be? 80 what? 80 squared. Minus, then you stick in a 4, and then you put an a and a c. What's our a? Negative 16. What's our c? 3.5. It's just plug and chug, isn't it? You already got your formula. All you're doing is just taking your numbers and you're just throwing it into your formula. Okay, so the hardest part about this is just simplifying everything once you got everything in here. You're not really doing any algebra. This is just arithmetic, really. That's all it is. All right, and what's the bottom? 2a, right? So 2 times what? Negative 16. Good. All right, it'd be nice if that was our answer and we just circle it and we're done. But no, we got to simplify it, all right? You got to take it down. And what we're going to do is, since it is time, we're not going to like leave our answer as a square root or anything. We'll actually take it and put it into our calculator. If you can take all of this and chuck it in your calculator all at once, there is a possibility that you can do that. To me, I think you're leaving yourself open to make all kinds of mistakes, okay? If you just take all that and say, okay, I'll just use my calculator. Negative 80 plus or minus square root, da-da-da-da-da. You could do that, and it's definitely possible to do all that stuff. But I'd be very, very careful if I were you about it. I like to take it a little step at a time. So I'm going to keep that negative 80 on the outside. I'm going to put that plus or minus there. I'll put a big square root there. And let's see if we can simplify some stuff inside of this. So you got 80 squared. Actually, I didn't do that particular step, but what I would do is this. You could do all that in your calculator, couldn't you? So you could do 80 squared. What's the sign going to be? You got negative 4 and negative 16. What's that going to be? It's going to be positive, isn't it? All right, so you could put 80 squared, that's 6,400, right? And then plus 4 times 16 times 3.5. You could do all that stuff and come up with 6624. I mean, that's still a lot to put in your calculator, but it's not as much as putting the whole thing in the calculator. But again, like I said, I'm going to reiterate, you could put all that stuff in your calculator all in one shot, especially if you had a graphing calculator. It works a little bit better than if you had like a little tiny scientific calculator. Because they show you every number you're putting in. I think if you're going to use a calculator, use a graphic calculator. That'd be a lot better. But this is what I would do if I was to do it, just especially if I don't have a graphic calculator. I would do what I'm doing right there. And this is over what? Negative 32. Agreed? Okay. And then really, since you're using a calculator for this, now not every problem are you going to use a calculator. Sometimes you just want to simplify it and keep it as an exact answer. What we're going to get here once I put it into a calculator is going to be an approximation. It's not going to give me an exact answer. It's going to give me an approximate. But for physics, when it's asking for time, that's perfectly fine. Okay, I wouldn't tell somebody the time as, I don't even know what this, it's negative 80 plus square root of 6624 over 32. I mean, that'd be ridiculous to say that's how long it takes that rocket to go from here to here, right? You want an actual time. You just want a number in seconds or minutes or hours or whatever it is, and then that's what we're going to do. So what I would do, you're going to get 2 times because you got a plus or a minus, correct? So what I would do is put the first one in there. I would just go negative 80 plus square root 6624. And you can do all this on the calculator. It's perfectly fine. Got no issue with it. Over 32. And you do the first one with the plus, and you get negative 0.04, and this is in seconds. It's in time. All right, so it's negative 0.04 seconds. Now, let's be careful before we circle that. So tell me about that. Does anybody have an issue with that answer? It's negative. What's wrong with being negative? We get negative answers all the time. You can't have negative time, right? You can't go back in time, okay? Unlike all the movies where they go back in time, can't happen, all right? Hate to burst your bubble, but it can't happen, all right? So you can't have a negative time. So this is not going to be a valid answer. If they were not solving for time, if it just was solving for x, that would be okay to have a negative answer, all right? But in this particular problem with time, that's not going to be a valid answer. I'll mark that out in a second. Let's find the other time. What's the other time? Well, it's negative 80 what? Minus square root of 6624 over negative 32. You got to practice these with your calculator, okay? Just because you have a calculator doesn't always mean you're going to get the right answer. Okay, you got to be really careful. You got to be careful with your calculator. So make sure that you're getting these answers. Practice that on your own, whether you're doing it now or when you get home. Make sure you practice it. On this one, you get 5.04 seconds. And that is positive. So which one are we going to use? We're not going to use that one because it's negative time. This is the time that we're going to use right there. Okay? Put it in the calculator. I'm not going to show you how to do it. You can do it. You guys can push buttons. So put that into a calculator. Make sure it comes out to that. And that's what you should get. We good? All right, let's do another one. This one's kind of more normal, I guess, if you want to call it that. Oh, by the way, let me talk about this. No, save that for later. Let's do this, example 4. It says solve by using quadratic formula. It really doesn't matter. But if you wanted to try to factor it, we'll talk about that here in a second. So if you look at this, when we first started doing these quadratics, we learned how to factor. It's a trinomial factoring, right? X squared x and then a number. But can we factor this? Can I do this? Don't write this down. Don't write this down, what I'm writing right here, these parentheses. Okay, stop it here. You can write that down, okay, but don't write the parentheses down. Can you factor it? X and x. Can you get 2 numbers that multiply to be 15 and add up to be a negative 4? There's not. I mean, think about it. You got 1 and 15. Is there any way you can get a 1 and 15 to be a negative 4? No. What are some options for 15? 5 and 3, right? Is there any way that you can manipulate a 5 and a 3, whether one's positive, one's negative, or they're both negative or anything like that, to get a -4 out of it? There's not. So there's no way you can factor that. Do you agree? So factoring is off the table. We can't do it. Look at this. I wasn't planning on doing this, but I'm going to. Let's go to this. Let's go to Desmos. I got to change mine. Desmos right there. Let's get rid of that. Make sure I go back to that other stuff, okay? Because it'll just show this the whole time if I don't go back to it. Oops. Where I went? I went this. Okay. So let's put this in here and let's see what happens. When I'm solving for x, do you remember the phrases that we use? If I'm getting a value for x, I'm finding the zeros or the roots. Do you remember me saying that? Find the roots of the equation or the zero of the equation. What does that mean? That means where it crosses the what? The x-axis, okay? So let's put this in here because we might be able to solve this by graphing, okay? Put it in Desmos, find out where it hits the x-axis, and then we should be good to go, right? So let's bring this thing up. Let's put x squared. So x squared was at minus 4x, right? Minus 4x. And then, what was it? Plus 15? Plus 15. Look what happens. And that, we're just going to do that. Oops. What happened? Why isn't it on the graph? There it is, because it went up 15, didn't it? Do you see that? So where does that graph cross the x-axis? It doesn't cross the x-axis. So that means there are no real solutions for that equation right there. Okay? That means, now I emphasize real. Why did I say that? Because there could be what? Imaginary solutions, okay? Or complex number solutions, okay, for our value. So there's no real solutions. So you cannot graph this thing and solve for x. You just can't do it. Everybody got that? You can't factor it. Remember we went through that whole list of 4 things? But you could do it by what? Say it again. Quadratic formula, not equation, but quadratic formula, or what? What was the other one? Completing the square. Okay, now they don't ask you to do it both ways, and another problem they do, so I'm not going to do it both ways on this one, but you could if you wanted to. Let's just use, to me, remember I said it's kind of weird that they'd use that other example as your very first example, right? This is the kind of problem I would use, but I think I know why they didn't, because we do come out with imaginary number answers, okay, or complex number answers. So let's do the formula. If you're still trying to remember the formula, I would write it down every single time. I would not just put it up on top of my paper and just refer to it every time. I'd write it down every time, okay, if you have a hard time memorizing it. So it's negative b plus or minus square root b squared minus 4ac. That whole thing is over what? 2a. I'd write it down every time I had to use it, all right, so that you remember it. That's the reasoning behind it. All right, so now let's plug everything in. If you wanted to, you don't have to, but some people like this, so I always show them. You could list your A, B, and C. So what's your A in this situation right here? It's 1. That's very good, because that's a 1 in front of that x squared. What's the B? Not 4. It's a -4. You always got to take the sign before it. That's what the sign of it is, okay? And what's the C? Positive 15. All right. So sometimes that helps. I don't know. Does that seem to help, writing them down like that? All right. And at first, it's good to do that. A little bit later on, you probably don't have to do that. So let's keep going. Now, let's plug it into our formula. So x equals negative b, the opposite of b. Well, b was -4, so what's the opposite of -4? It's positive 4. So it's going to be a positive 4 plus or minus square root b squared, so -4 squared. Let's just do that in our head. What's -4 squared? It's positive 16, right? Because -4 times -4? Yep. Minus 4 times a, which is 1, times c, which is 15. That whole thing is over 2 times a. or just 2 because it's 2 times 1, right? I don't even need to put the 1 there. I just put the 2. Let's simplify this. I would not use a calculator on this, all right, because you want, first of all, look at inside the square root. Here's what I was contemplating talking about this earlier, but I'm going to talk about it right now. Do you see all the stuff inside that square root? They give that a name. They call it the discriminant. You ever hear that word? Probably not. Discriminant. I don't know, maybe if you learned quadratic formula before, maybe your teacher did say this word. But what is the discriminant? The discriminant is b squared minus 4ac. It's all the stuff inside. It looks like an E. Make it look like a C. That still looks like an E. There we go. All right. So all the stuff inside that square root is called the discriminant. Now, in order to get a real number answer, what must be true about the discriminant in order to get a real number answer? If you got a real number answer, what must be true about that b squared minus 4ac? It's got to be positive. Or it could also be what? It could be 0 too, right? Because if that comes out to 0, we can get a real number out of that. Sure. So it's got to be greater than or equal to 0. What if you get an imaginary number? What would the discriminant have to be to get an imaginary number? Well, to get an imaginary number, that means you're taking the square root of a negative number, correct? All right, so b squared minus 4ac must be what? Less than 0 if you're going to get an imaginary number. So you can kind of get an idea before you even throw the numbers in of what this is going to be. Because 4 times 15, what's that? 60, right? 16 minus 60, it's going to be a negative number. So guess what? Are we going to get real number answers? Nope, we're going to get imaginary. We're going to get an I in there somewhere. So that's always nice to be able to see. You with me on that? All right, you didn't have to know that, but I think it's good to see. All right, let's keep going. So it's going to be 4 plus or minus square root. We already talked about this. 16 minus, what did I say that was, 60? What's 16 minus 60? Minus what, 44, is that right? Okay, over 2. Let's keep going. 4 plus or minus. Let's simplify the square root of 44. I'm going to do this off to the side here. Square root, I'm just going to put a 44 here, even though it's a negative. What happens to that negative inside that square root? What does that become? Becomes an I, doesn't it? All right, we can put the I in front. It's a big old I. You can put the I out in front, or you could put it at the end. I think this book kind of likes it in between there. So let's figure out the square root of 44. Well, that's 40. That's the square root of 4 times what? 11. What's the square root of 4? It's 2. Square root of 11. See that? So the square root of 44 is just 2 square root of 11. So we could just write 2 square root of 11. And that's all over 2. Looks like it's simplified, but it's not. Why? Because everything's being divided by 2. See if you can do this. You could write them, separate them. You could go 4 over 2 plus or minus I 2 squared of 11 over 2 and then cancel them. But look what happens. Let's just do that. I probably should do that. So watch. It's this over 2. So this is 4 over 2 plus or minus I. Actually, you know where they like the I in this book? They like the I in between this number and the square root. All right, so I'm going to put 2I square root of 11. Everybody understand why I'm doing this? Because everything's being divided by 2 here. So this first term is being divided by 2 and the second term is being divided by 2. So we're almost there. We almost got our answer. 4 over 2 is 2 plus or minus. What happens here with these 2's? They cancel each other out, don't they? Oops. And then what do I have? I got I square root of 11. I told my last class, because we just did complex numbers for the first time just the other day in my Algebra 2 class. I used to teach out of books that would rather put the I, I'm going to put an or. 2 plus or minus square root of 11. See, I feel more comfortable putting the I out here like this, but this book likes putting the I in front. I like this because it's a plus bi. Would you agree? It's not a plus ib, right? But it seems like this book always likes the I in front of that number. But I like it on the end. So either one of those is perfectly fine. And that is your answer. It's actually 2 answers, isn't it? How did I know I was getting 2 answers? Because I started off with x what? X squared. Okay, so whatever the highest degree is, that's how many answers you're going to have. Right? We talked about that the other day, I think. What do you think? Quadratic formula is pretty easy, isn't it? Just plug and chug, right? Just plug the numbers in and then just work it out and simplify it. That's all you're doing. You're just simplifying stuff. You're really not solving. You're not really doing any algebra. Let's put it that way. All right? You are solving for something. You're solving for this, but you're not really doing any algebra. So that's kind of nice. All right, let's do one more and we'll quit. Even though, yeah. This is the problem. I could take a long time on this, but I'm not going to. This is the problem where they ask you to do it 4 ways. Okay, so here's the problem. It's 6x squared plus x plus 2 equals 0. And I'm trying to solve. Trying to get x by itself. Now, I could put this in Desmos and graph it. Did I go back to this, by the way? Yes, I did. Thank goodness. Okay, so I could put this in Desmos and find out that it's not going to hit the x-axis, so there's no real solutions for this, which means I'm not going to be able to use graphing to solve for it. I'm not going to be able to see where it hits the x-axis because it doesn't hit the x-axis. So graphing, we can't do it. Okay, factoring. Here's another thing. Do you remember the discriminant? If the discriminant is negative, we're not going to be able to factor it. So what would the discriminant of this be? It's b squared minus 4ac. Let's do it. What's the b? 1 squared, right? Minus 4 times a, which is 6, times c, which is 2. Right away, you can see that's going to be negative, isn't it? So if your discriminant is negative, you're not going to be able to factor it. All right? So we can't do it by factoring. So we got 2 other ways to do it. What are my other 2 ways? Solve by completing, what's the first one before we did quadratic formula? Completing the square, we could do it that way. Or we could use, well, actually, they want you to do it both ways. They want you to do it by completing the square, and they want you to do it by the quadratic formula. If I had more time, to tell you the truth, 10 minutes, I probably could squeeze both of them in. But I can see by your faces, you're bored to death. So I'm just going to do it by quadratic formula, since that's what we're learning today. All right? So let's use the quadratic formula. Let's write down the a, b, and c. So what's the a? It's 6. What's the b? It's 1. What's the c? It's 2. Do you have the thing memorized yet? Quadratic formula? No response? All right. All right, so there it is. X equals, I should put. Okay, so x equals that. That's your quadratic formula. So now let's plug stuff in. Negative b, or the opposite of b. Well, b is 1, so what's negative b? It's negative 1, plus or minus, square root, b squared. Well, b is 1. 1 squared is 1. Minus 4 times a is 6, times c is 2. Over, that whole thing is over 2 times a, or 2 times 6. And now it's just arithmetic. It's all it is. Okay, just plugging numbers. You already plugged it in. Plug and chug. That's what I like to say. Now you're chugging. All right, you're doing the work. So we got negative 1 plus or minus square root. Let's do this. Can we do this in our head? 6 times 4, or 4 times 6 is 24, times 2 is 48. 1 minus 48, negative 47. Okay? Over 2 times 6 is 12. Look how easy this is. I might have time to do it by completing the square. Negative 1 plus or minus. What do we do with that negative inside that square root? It becomes an I, doesn't it? Square root of. Now, can I simplify the square root of 47? I think 47 is prime, isn't it? 2 doesn't go into it. 3 doesn't go into it. 4, 5 doesn't. 6, 7. 7, no. 7 times 6, 42, no. So, yeah, I think that's prime. Over what? 12. That's it. Look, that was easy. If I can get my pen to write. There we go. So what do you think? You like that quadratic formula now? Yeah. Let's do it. We got time. I didn't think that was going to be so easy. Let's do it by completing the square and just compare them. Okay? Maybe you like completing the square better. I don't know. But completing the square is kind of new to you. I think we kind of ran through it pretty fast last time we talked about it. So I think it's probably good that we do it again. So let's write it down again. 6x squared plus x plus 2 equals 0. All right. First thing we do in completing the square is we, if you want to see, I was going to say a real good lesson. I don't know if it's a real good lesson, but a thorough lesson on completing the square, watch my Algebra 2 video tonight that I shot today. Just go to the Algebra 2 channel, right, and watch the one that we did today, and it'll give you a good explanation of this, all right? So, because I kind of rushed through completing the square with you the other day. Like I said, the book kind of expected you to know how to do it. First thing I do is I want x squared by itself. So how do I get that? How do I get rid of that 6? I'll divide everything by 6 and divide that by 6. So let's see what happens when I divide everything by 6. That cancels. I'm left with x squared. Now watch how I'm going to write this. I want to write this so there's a b. What would the b be? It's 1/6. Good. It's 1/6 x. Would you agree that's the same thing as x over 6? Yeah. But I wrote it so it's got a coefficient. Plus what? 1/3 equals 0. Now, this is not a perfect square, all right? I can't take the square root of this, okay? There's nothing that I squared to get 1/3. So what I'm going to do is I'm going to take this and I'm going to chuck it to the other side and I'm going to replace it with a number that I can take the square root of, okay, to make it into a perfect square. So this is what we do. I mean, we did talk about this on Friday, so you can watch that video too, but I think I went a lot quicker than I did today in my Algebra 2 class. I'm going to put plus and I'm going to put a blank right here because I want to put a number in there that's going to make this into a perfect square. If I move this over to the right side, I got to subtract it, so I'm going to get a negative 1/3. Everybody good? All right, so what do I do? See that blank right there? How do I find what makes this into a perfect square? Because here's what I want to do. I want to be able to do this, okay? I want to turn this into this. How do I do it? Well, I take that middle coefficient, that 1/6, I come over off to the side, I take half of it. I explained this on Friday, so you can go back and look where I'm getting this stuff from. And then I got to square it. And that's what I'm going to put right here. So let's multiply this. This is going to be 1 over 12, and that's squared. If I square that, that's 1 over 144. 12 squared is 144. So that's what I'm going to add to this, 1 over 144. But remember, I can't just arbitrarily just add something to one side. What would I have to do to the other side? I've got to add it to the other side. So I'm going to do that over here. So I'm going to add a 1 over 144 over here. By me taking half of the middle one and squaring it and putting it right here, that makes it into a perfect square. So what's squared, or what number, if I squared, am I going to get x squared? An x. Then I always look to that sign right there. That sign is what I put here. What squared is going to give you 1 over 144? 1 over what? 12, right? 1/12 squared is 1 over 144. Equals, let's figure out what this is going to be. Need a common denominator. Let's see. I don't have the math in my head. There we go. So what if I multiplied... What's 144 divided by 3? I think it's 48, isn't it? So if that's a 48, 48 times 3 is 144. So what do I do to the top? Multiply that by 48. So what do I got? I got negative 48 plus 1 over 144. Okay, all I'm doing is just adding these fractions to each other. So what's negative 48 plus 1? Negative 47 over 144. All right, so here we go. You're like, okay, Mr. Hammer, you convinced me. Okay, quadratic formula is way better than completing the square. And you're absolutely right. But let's finish this up, see if we get the same answer. I hope we do. Let's take the square root of both sides and let's subtract a 1/12. So I'm going to go minus 1/12 plus or minus, because we're going to take the square root of this, right? Take the square root plus or minus. Took the square to the left side, which cancels it out. So what do I get? Plus or minus the square root of what? 47. There's an I, so we're going to put the I here because the negative 1 over the square root of 144. What's that? It's 12. Let's simplify, or let's make it a little bit nicer. Instead of putting it over two different fractions right here, since you got the same one, we're going to write x equals negative 1 plus or minus I square root of 47 over 12. And that should look like the answer we got earlier. Does it? Yep, look at that. Which way would you rather do it? Look at the work involved here. So really, the only reason they did that is just to visually see that, yeah, there's definitely a reason to know how to do the quadratic formula. Wouldn't you agree? All right. I mean, completing the square is okay, but oh my word, look at all that we had to do. Look at all the places you could have gone wrong. All right. So definitely quadratic formula is the way to go. I'm all for it. So should you. Here's your homework. Section 4.2, pages 219, 220. And you're doing 13 to 33, but you're just doing the odds. Looks like a lot, but it's not near as much because you're just doing the odds. That was on the lesson plan I gave you earlier, but I was taking a picture of anyway, so you should have that already. Is that the same thing I gave you? I think it is. Sometimes I change it. Let me see. Yep, 13 to 33 odds. There you go. Okay. Get that done. That is for tomorrow.